We are looking at the tool set for problem solving, and in particular, we are looking at using the universal template for writing a problem solution. The very fact that it's a universal template, it means it can be used for any solution, any problem solution that requires a detailed explanation. So wherever you require a detailed explanation, not the objective type of questions, but wherever you need to give a detailed explanation, which may be for your GCSE exam or the board exam, or most importantly for the Olympiad exams, wherein you're expected to write a detailed solution, this template can be used. Now, the good thing about this template is, first of all, or before that, let's talk about the bad thing. The bad thing about this template is, it may sound very boring. You may all be used to writing the solution in a particular fashion, in your own style, in your own free form manner, which may not be which may not be consistent with what your other peers or colleagues or friends are using. So you may find it a bit more boring and cumbersome to fill this template, to discipline your writing in a particular format. But the good thing is, if you make it a habit, if you make a habit out of following this template, then you'll eventually see, very soon you'll see that this template is helpful in terms of bridging the gaps in your thinking. So wherever you'll find some difficult problems which you are stuck with, if you just follow the discipline of following the template will prompt you in the right direction. It will say that, no, you need to fill this a table, or you need to draw this diagram, or you need next step is basically to get the equations. That will prompt you in the right direction and bridge any gaps that you have in your thinking. Now, this template is based on the generic approach to problem solving, which we learned about in one of the previous tools. The generic approach of problem solving, will not go through it in a detail, but it has got various components. It has table, diagram, solutions, starting point, X factors, assumptions, objectives. Uh, no, the various components of this generic approach are captured in the template. Now, before I share with you the template of writing your solution, let's talk about the flow of argument. As we know, in the generic approach to problem solving, you have a starting point and you have an objective. You first of all identify what objective you need to achieve in terms of solving the problem, and you find a very initial easy step. The first step is always supposed to be most easiest, which is based on the information given to you. And the approach is to follow a step-by-step fashion in moving in the rightward direction till you come to a point wherein you have answered the question. Now, your flow could be either in the forward direction or it could be in the reverse direction. So, your written solution should be in the flow. When I say it should be in the flow, it means it should be seamless. It should be seamless. It could be either in the forward direction or it could be in the reverse direction, but it should be seamless, and which makes it much easier to read. No, if I give you a comparison with another solution which is written in a very different way, in this, you start with a starting point, and then you, based on the starting point, you come to some intermediate conclusion, which is this one. And then from this step you arrive at some conclusion, which is here. And then once you reach here, you realize that, you've missed out giving an explanation of an intermediate step, so you go back. And then, from here again, you change your direction of thinking and give another intermediate step. And then from here you do you come to this point, and then you realize that, by the way, I've arrived at this point because of this reason. And then from this reason I arrive at this intermediate conclusion. And then finally, out of all of it, I come to my answer. Now, this is what we call as the monkey jumping solution. You're moving forward and backwards. You're moving in forward direction and in backward direction. It doesn't give a seamless experience. It's not a good solution to read, to look at. The impression that any evaluator gets out of it is, you're not clear in your thoughts. It's not a very clear. You're not clear in your thinking, as compared to this one, wherein it's a very, very seamless approach. From this step, you arrive at the next step. From here, you arrive at the next step. And there is a very logical flow in your argument. So just be careful about choosing the approach. You should be always using a seamless approach, which could be either in the forward direction, which is from starting point to your objective, or it could be in the reverse. If this is the objective, I let's assume that this is correct, and from this I derive at this, and from that I derive at it, and you go in the backward direction till you come to a point which is inconsistency with the information given to you in the question. So in either way, whether you're moving the forward or in the backward direction, make sure that your argument is seamless. Other point here is I gave this feedback to a lot of you, and in Olympiad, many of the explanation that you've given is too short. Which means you've arrived at the answer. You arrive at the answer, which is good, yeah. But that's not what you're at least at the Olympiad. That's not what they are really interested in. For an Olympiad solution, you got 20 minutes for on an average for a single problem. Yeah, you got 6 questions, 20 minutes, 2 hours to solve. Okay, the emphasis is to make an argument which is foolproof. I keep on repeating that it should be a foolproof, which means that you cannot be challenged. Okay, if you look at it, if you look at your answer, it is based on the your entire solution is based on some building blocks. Let me introduce this concept of building blocks. So your answer is you arrive at the answer by writing your solutions, which may be a few steps, yeah. You arrive at the answer which is based on a solution. You follow a process of solving the problem to arrive at the answer. Okay, so your answer is based on some solution. Now, so your solution may involve, it may be involving solving equations or doing some calculations. Okay. Now, this in turn, your solution is based on some basis of solution. You're not just solving it just out of it. Before you come to the equation, you are making before you solve the equation, you are first of all making an equation, and that making the equation, which means you're introducing some variables. You're making some assumptions that speed is s, distance is d, and time is t, so that you can make an equation that d is equal to s times t. Yeah, before you come to the equation, you're making some assumptions about the variables. Yeah. So the basis of solutions is the assumptions that you're making, the table and the diagram that you're drawing, so that from that it becomes very clear as to what calculation I have to do, or what equation I have to solve. Okay. Now, even these basis of solution should be based on some very fundamental concepts of math, which are kind of undeniable laws. Can you give me an example of an undeniable law on the basis of which you can make a solution, which could be the basis of your solution? Okay, that's a very good example. When you say that only even prime number is 2, it's something that cannot be challenged. Yeah. So if in your solution, if you are basing your answer to some solution which is based on some diagram, table, and assumptions, and the basis of it, the very fundamental layer of your solution is an undeniable law, and if I'm writing it all, I'm taking care of each of these layers, my solution cannot be challenged, because it is based on a very, very strong foundation of a universal law, that the only even prime number is 2. Okay. Or it could be that the very fact that an even number when added to odd number is an odd number. That's a very strong foundation. You can't be challenged on that foundation, isn't it? Yeah. Or the sum of three angles in a triangle is 180-degree. If it is based on the premise that sum of the three angles is in the triangle is 180, and I base my solution based on this undeniable law to come to an answer, I have a complete solution. Or the fact that a left hand side of an equation is a multiple of 5, then right hand side also has to be multiple of 5. So what it means is your entire solution should actually drill down to some undeniable law. So the detail in which you're writing your solution should be such that for everything that you're writing, for every answer that you're writing, there is a solution. For arriving at a solution, you have some basis of your diagram, table, and assumptions. And at the very foundation layer are some are references to some undeniable laws. And if I take care of all of it, your answers are is a complete answer. Before we move forward, is it making sense? I mean, it may seem very abstract, but is a part of it making sense? Are you able to relate to it? Okay. Now that brings sounds good. Sounds good. Okay, so the reason why I'm saying here is, in Olympiad you have to take care that you're not just giving the answer, or not just giving a superficial answer which is based on some vague solution which is not based on reference to the foundation, universal undeniable laws of maths. Your solution should drill down to, for every statement that you make, every statement that you make, every step that you take, it should refer to an undeniable law, so that if a questionnaire attacks you or challenges you as to how have you arrived at this answer, how have you arrived at this solution, what is the basis of this equation, how have you solved this equation, you've solved this equation, but what is the basis of it, you have not made your assumption. How do I know that s means speed? Where have you mentioned that time is represented by t? You've solved that s is equal to d over t, but s could be anything. Yeah, you should not be challenged, you cannot be challenged. And if your solution is complete, which what it will entail is, you can the challenge can come from any direction, for any of the steps, for any of the statement that you have made. If your answer is complete, any pressure that you face from the challenges can be brought down from answer to the next layer, to the next layer, to the very foundational layer which is undeniable. You can't just deny these concepts, these mathematical laws. That's the sum of the three angles in triangles 180 degree. So if you have mentioned in your step that I'm doing it because I'm using the fact that sum of three angles in a triangle is 180, there is no basis for challenge, you can't be challenged beyond that. And that's what your Olympiad evaluator will be looking at. They're not just interested in answer, they'll give you sufficient time to justify your answer. Every single step that you make, every single statement should be justified, and should be justified by an undeniable principle. So, in that sense, your solution should be like the roots of a giant tree. Yeah, if you have got a very deep and very strong roots, then the tree can withstand any storm, any challenge. Yeah. So likewise, if your solution is rooted in some undeniable mathematical concepts, if everything that you write in your solution is based on some undeniable laws of mathematics, it can withstand any challenge, it can withstand any attack, because ultimately all the pressure that you're getting from challenges and attacks is being passed down to the very basic building blocks, which are undeniable, which cannot be challenged. So now let's look at the model answer, as to how the model answer should look like. Yeah. So your model answer should have a few few sections, which is what we'll call it as a template. So in the template solution, there will be a number of sections. Not all these sections are applicable to all the problems, but as far as possible, your default position should be that you should have all these sections. You should be writing down all the sections, and if you feel that some of the sections are not applicable in the problem, you can eliminate them. But by default, your thinking should be, always follow the template. Always first start with all the components of the template. If you feel some of the components are not required, you can eliminate them. So what all should your solution entail? The first thing is, it should have an it should have an objective. Now you need not be writing the objective in your solution. It may be as simple as just highlighting the objective in the question given to you, in the question paper given to you. You just highlight the objective. You may not be actually writing it in your solution. The idea here is, you need to be very clear about what is the question, what question needs to be answered, or what hypothesis needs to be proven. Many times we make the mistake of assuming, thinking that we know what the question is and we solve it, and then eventually we realize that even though our explanation is all correct, but we have answered a wrong question. We have given an answer which is correct, but then it is to a wrong question. So it's always, you should be always clear as to what your objective is. So this particular, the objective part is in the generic approach of problem solving is, this section. So this is what your template is, should have. The second point is the assumptions, yeah, which is like, for example, let the unknown length of the radius of the circle be r. Yeah. Now your assumption, if you see the generic approach to problem solving, the assumption you make at a quite a later date. You make the assumption only when you get stuck. All your in a generic approach, you're making the tables, making the diagrams, you're finding the starting point, and you're moving forward. You make an assumption only if and only if you get stuck. But in your template, in your solution template, your assumption should be at the top. Yeah, you should always be collating all the assumptions in the top while you're writing. So what it means is, you may be actually solving the problem, but as soon as you hit a roadblock, when you are making an assumption, go back to the top section of of your solution, and go back to the top section of your solution template and note down all the assumptions. If you get stuck 3 or 4 times, if you're making 3 or 4 assumptions, then all those assumptions should come together in the same section, which is at the top. So after the assumptions, then the next thing you have to take care of is the diagram, which is a pictorial representation of the information in the question. As they say, a picture is better than 1,000 words. So this, you should be, um, you should be drawing a picture which truly depicts the problem. Yeah, this is the section. After that, or along with that, or it may be either or between diagram and table. You should, as far as possible, use table. Yeah, you should be representing your information and the steps in a tabular fashion. Yeah, it's much better than writing long paragraphs explaining something. If you just draw a table, it's a nice view, much more better way of representing the information than writing big long sentences. The table is in the generic approach is here. Now you may have to choose between diagram or table, or the sequence of in your solution attempt, your diagram may be coming before the table, but just be careful that you're not writing long sentences. As far as possible, you're translating them into a table. And then we have the step-by-step solution. Each step should be numbered in the logical order. So when you come to the step-by-step solution, which is here, uh, uh, all the steps that you're taking, all these steps should be numbered so that you can refer back, based on the step number 5. This is my conclusion is, or based on step 5 and step 8, I can conclude to this answer. So all the steps should be answered, and within the steps you will find that there are equations are basically converting the English sentences into mathematical equations. All the equations should be numbered. They all should be having a number so that you can give a reference, saying that by adding equation 2 with equation 4 I get this, or if I subtract equation 7 from equation 3 I get that. So all the equations should be numbered. And then finally, in the last step, your answer should be clearly highlighted. It should be enclosed in a box or highlighted in a different color. You should make a distinction that your answer is clearly visible. Yeah, there should be some marking on the answer so that because it's the final step, it's the very last step. It should be very clearly highlighted. Again, I repeat, not all these sections are applicable to all the problems, especially in the multiple choice question. You're not following any of these steps. You're not writing any of these blocks. But wherever you need explanation, you should be sticking. You should try to stick to all this by default. And once you make a habit out of it, you will notice that this discipline itself is prompting you in the right direction. So we have looked at what the flow of your argument should look like. It should be seamless. We also looked at how deep rooted your solution should be. in the basic undeniable concepts of maths, and we have also looked at the template that you need to write your solution into. Let's apply all of it together in an actual problem. So in this problem, it is a diagram given, and you're supposed to find the value of p plus q plus r plus s plus t plus u plus v plus w plus x plus y in the diagram. So p q r s t u v w x y are all the angles given. You're supposed to find the sum of all these angles together in this pentagon. So the first thing is so you're not writing the objective here, but just to be very sure it's visible in front of you, you're highlighting the objective. The objective is to find the sum of these angles. The next thing that you do is to write the assumption. Now you'll not come to the assumption straight away. You will be actually drawing the diagram, but then realizing that you're stuck in the problem, and then in order to move forward, you have to make assumptions. And at this point, when you're making the assumption, but once you've made the assumption, you will write it down in the top section. The top section of your solution should be assumption. So after drawing the diagram, you got stuck, you made the assumptions, and then you're writing the assumptions, coming to the top of the section and writing that let's assume that the internal angles in the pentagon are A, B, C, D, and E as shown. Yeah. Then of course there will be a diagram section in which you're replicating this diagram, and then you're updating the diagram with the information given derived in your solution, and also the assumption that you're making. So once you have written your assumptions, drawn your diagram, then we'll come to the equations. And the equations, as we've seen, as we have discussed, it should be based on some fundamental, undeniable mathematical principles. So the first principle that we're using is that if two lines are intersecting, the opposite angles are both equal. So if you see, angle Q and R are equal because Q and R are formed by these two intersecting lines, in which Q and R are the opposite angles. So both of them have to be equal. Likewise, S and T is angle S and T are formed by two intersecting angles, and they two intersecting lines, and they are opposite angles in the two intersecting lines, so they should be equal. This is an undeniable law. Yeah. So based on this law, we derive all these equations. Similarly, we use the fact that angles in a straight line add up to 180 degree. Again, this cannot be challenged. This is very fundamental. So if you see, if you look at the straight line, this straight line, this straight line which is moving in this highlighted here, the sum of angle A and angle P together makes a straight line which is of 180 degree. So A plus P is equal to 180 degree. Not just plus P, but even if you look at this particular straight line, the angle A and angle Y together make a straight line which gives you 180 degree. All the equations that you're deriving it are all marked. So this is equation 1, 2, 3, 4. So you're highlighting all your equations with a number. So using this particular law, you get all these equations. And then finally, you're using another mathematical truth, that sum of all the internal angles in a pentagon is 540 degrees. So if you add up all the internal angles, which are A, B, C, D, and E, they add up to 540 degree. So that gives you another equation. Once you've noted your equations, then you'll come to the solution, and again, while following the solution, you'll follow a step-by-step fashion, and as far as possible you'll try to tabulate it. So the first, remember, when you come to the solution, you have to keep in mind what your objective is. Your objective is to find the sum of all these angles. Yeah. So you'll try to use these equations which are available in front of you. You'll try to use this equation in such a way that you are ultimately getting the sum of all these angles. Now it becomes very obvious, if you look at the objective and the equations given to you, it becomes very obvious that in order to get the sum of p, q, r, s, t, u, v, w, x, y, etc., you need to add all these equations. You need to add all these equations. That's why, having the objective in front of you, alongside the equations that you've arrived at, using the fundamental principles of maths, having both of them together makes you helps you in deciding as to what your step should be. The step is to add the equations 6 to 10. So if you add up all the equations 6 to 10, if you add up along this column, A plus P, B plus R, C plus D, D plus V, and E plus X, you get this. Again, you can club all the A, B, C, D in single bracket, and all the PQ, RST, UV, X in another bracket. And then on the right hand side, you get 180 times 5, which gives you 900. So let's call it as equation 12. Here we have only added these 5 elements. Now look at these 5 elements, and again if you add, you'll get A, B, C, D, E together in a single bracket, which is here, and then you will get Y, Q, S, U, W, which is in another bracket, which is here, and together on the right hand side you get 180 multiplied by 5, which gives you 900. Let's call it as equation 13. Then again, go back to the objective. The objective is somehow to add these two, the objective is to find the sum of these all these angles. In order to meet your objective, it becomes but obvious that you need to add equation 12 and 13. If you add equation 12 and 13, you get this particular bracket twice, which is given here, and then your objective, which is to find the sum of all these angles. And on the right hand side, a 900 and 900 gives you 1800. Yeah, so you're explaining, you're describing what your step is, and then you're following that step. And then finally, you notice that in order to achieve it, I know this is as a number, right hand side is a number, the left hand side has got the objective, and it has also got one bracket which I need to somehow get rid of by converting it to a number. And then if you look back, basically equation 11 gives you the value of this bracket. A plus B plus C plus D plus E is 540, so you can replace this bracket by a 540 here, and that gives you your equation 14 in the last step. And then it becomes very easy that you take this 2 times 540 to the right hand side and subtract it so as to get your answer, which is 720. Your answer is very clearly highlighted, making it distinct from all other steps, because it's the conclusion, it's the very last step. You're you're confidently declaring that this is my answer, and you're highlighting it. If you look back, it has got all the elements of the template. It has got the objective, it has got assumptions, it has got diagrams, it has got all the equations marked. We are using the fundamental concepts, everything, it cannot be challenged, because you have derived this equation from a very, very unchallengeable mathematical concept. And then finally, when you come to the solution, you are taking a step-by-step fashion. You're keeping your objective in front of you and the equations that are available to you and the diagram in front of you, and then you are you're gradually in a step-by-step fashion moving towards your objective, making sure that you're tabulating all, instead of writing long sentences and big paragraphs, you're giving it a very, very clear tabular solution, and then you're finally coming to the answer. Now, any evaluator who reads it will be impressed by the clarity of your thought, the flow of your thought, and how you've used the tables and diagrams to cut down on long sentences. Yeah, this is one example. Have a look at it. Let's look at another such example wherein this template is used. I'll not go through this in detail, just focus on how the template is used. This is the long questions, clouded question. You have highlighted what your objective is. Need not write it, but just keep it in front of you so that it's always in the mind. You have noted all your assumptions here. Your assumptions you might have derived at a later point in your solution approach, but then you're still it should be the very first block. Yeah, you have assumed that the speed, distance, time are here, and then you have drawn a diagram here. Yeah, so that it becomes it gives good pictorial view. You have given some basic fundamental mathematical concept. This basic relation that you've used is that distance is speed into time. This is something that cannot be denied. It cannot be challenged. So if this is the basis of your solution, then you're on a very, very strong foundation. No one can challenge you. Yeah, and then you get all your tables and equations. We'll not go through in details, but then for the three cases that you have about the travel, for each of the three cases, you made a table, and you've derived the time at which this person reaches the top of the mountain, the time has taken, the speed, and then you use this fundamental mathematical concept to relate the distance, speed, and time, and from that you get equations. And then you have once you have all these equations, keeping in mind what your objective is, you're taking a step-by-step fashion by manipulating your equations so as to finally come to conclusions. So these are all the intermediate conclusions, and finally your objective was to find the speed, yeah, which is this. Okay, you take have a look at it, have a read at it at your own pace, but just let's rush through another template solution example. Again, the objective here, in this case we have actually written the objective. You need not write it, but at least highlight it. So objectives here, you got the assumptions, you got the diagram, and then you've got the tabular solution, which helps you in tabulating all the information given to you. You use the basic fundamental mathematical concept that the area of a square is the square of its side, and the area of a triangle is pi into the square of its radius. Yeah, you're using this mathematical fundamental concepts, and then you come to the final solution, which is in a step-by-step fashion, leading you to your objective. And once you come to your answer, you're clearly highlighting it. As you can see, with all these examples, it may be a bit cumbersome in writing this in this particular fashion. If you make a habit of it, trust me, it's going to help you immensely when you're hit with a difficult problem, because the rigor, the discipline of following the template will lead you in the right direction.
You have just seen a free sample video in which just one of the many tools in our problem-solving toolkit was practically applied to solve just one very difficult problem. To get even more benefit, please also have a look at the other videos available on a variety of problem-solving tools offered to you in our toolset. However, just watching these sample videos is like just glancing at the tip of an iceberg, whilst much more remains unexplored. It's like only watching the entrance of a gold mine without entering it, when the entire gold mine is available to you up for grabs. If you want your child to become proficient in solving hundreds of the toughest problems that any child in their age group will ever solve, anywhere on the globe, if you want these techniques, the entire problem-solving toolset, to become a natural instinct, then please sign up with YoungThinks. YoungThinks courses are available according to age group and will expose your young thinker to hundreds of such problems, till a point comes when these tools become an inseparable part of their brain's DNA. Something that they will invoke automatically and unconsciously when they face a problem. For a moment, think of the mental and intellectual transformation brought about by such a course in your child. Think of the confidence your child will possess once they internalize the full Thinking Skills Toolkit. Visualize the attitude with which your child will approach their studies at school, including any subjects that they may find difficult at the moment. Think of the kind of adult your child will grow into, fully equipped with the Thinking Skills Toolkit. What kind of professional achievements can an individual who has the mindset of a problem solver reach? And to put it in a very crass way, what kind of earnings this individual who knows how to think and solve any problem will make? The success, once you achieve it as a problem solver, is not just restricted to maths or physics or subjects in your studies. It percolates to all walks of life. It makes you a well-rounded, confident, and complete individual. The fact that no school in the country, no tutor in the country offers it, makes YoungThinks courses a unique skill set to acquire. Now you may be wondering, who all have benefited from this course? The beneficiaries include 1. Child Genius National Finalists, 2. Prize and medal winners at National Maths Olympiad, 3. Children with IQs at par or above Einstein and Stephen Hawking, 4. Invitees of special summer camps at Oxford and Leeds universities, 5. National Team Maths Championship finalists, 6. Aspirants appearing in the entrance test to the best universities in the UK, including Oxford and Cambridge, 7. Achievers with the highest grades in GCSE exams. So don't hesitate. Register for the YoungThinks courses starting very soon and let your child make the most of them. To register, go to www.youngthinks.co.uk and click the shop page to find the full range of courses suitable for your child's age group. If you have any queries regarding the course, the registration, or the discounts available, it's best to give a WhatsApp call to the number appearing on your screen, or send an email to the address given here. Please do not hesitate to contact us and get the best possible advice. After all, the right course may transform your child's thinking and problem-solving abilities to a height that you can only imagine. Do not wait another day. Book your place before the registration closes, or contact us to discuss what is best for your child. We will advise you on the best options for you and your child, depending on your unique context.